Alrighty, well, hello everybody. How you guys all enjoying GitHub Universe? Right, so far so good? That is awesome. This is my first one actually, so this has been fun so far. All right, so hello everyone. I am David Jones-Gilardi. I am a developer relations engineer at DataStax. I've been coding for almost 30 years now in a bunch of different languages and such, but these days I am a GenAI nerd, totally focused on Python. Probably no surprise for anyone who's doing anything in GenAI. So, all right, the agenda. What are we going to do in the 25 minutes that we have here? So first thing is we're going to just quickly discuss the problem space. What's the problem we're trying to solve, right? Especially with RAG pipelines and such like that. It's good to have a nice little example of what it is we're doing. But to really understand what is going on with RAG and how to use it, you need to know a little bit about vector embeddings. So we're just going to do like the most basic primer ever and try to explain that and kind of demonstrate how they work and such. Then we're going to dig a little bit into RAG. I'm going to show you like a RAG pipeline. We're going to build one out real quick. But then the part that is, to me, the most fun part of this is generating a RAG app on the fly with Copilot, right? Like Copilot, like how many of you, we're at a GitHub conference, but how many of you have used Copilot now? All right, so everybody here is an expert on that, but like as like a code companion, right? I consider them like companions. It's pretty amazing, actually. And by the way, they literally just updated it like 20 minutes ago. And I was running through some stuff, and I'm like, oh, look, some things just changed. That's wonderful. Anyway, so so with that, all right, so the problem space. How many of you here have used ChatGPT, Anthropic, Mistral, any of them, right? Okay, most everybody at this point. Now, here's a question I have for you. What might happen if you went into ChatGPT and you asked an open-ended question like this? When did I start coding? What's it going to do? Right? It's probably going to give you an answer like this. I'm not sure when you started coding. I don't know who you are, right? At least we're well past the period now where all the LLMs are just hallucinating all the time, right? But it's going to tell you, I don't know why. It doesn't have context. It doesn't know anything about me, right? Unless you're a celebrity or something like that, or you have information that is very clearly out in the public sphere. It's the same thing for our business knowledge, right? For the internal data that we have in our business. Maybe it knows about your website, the front page or something like that. Hopefully it doesn't know about your business internals unless you wanted it to. But this is the problem we're trying to solve right here, is how do we then teach the LLM about the context of our data, right, and ourselves in our applications. Okay, so as I mentioned, to kind of understand this a little better, we need to know a bit about vector embeddings. So what are they? Embeddings are a representation of data that computers can easily understand. So I have a task for everybody here. What I want you to do is take these items, and I just mentally group them. I don't care how you do it. I'll give you a moment. I see all the light bulbs going and everything like that. All right, so there is a really good chance, even though every one of us have our own idea of what these objects are, you may not have grouped them exactly the same or anything like that, but there's a really darn good chance that you could probably be like, coffee and tea, they're related, they're drinks, maybe I have them in a mug or something. There's some animals on the bottom, but two of those are pretty much usually on a farm, they're domesticated, something like that. One, the tiger, we usually don't find those in farms or in our homes usually, right? Maybe in a zoo, maybe out in the wild, so they're related but different. Then you've got the computer monitor up in the top corner there, which is that's my generative AI version of Zork. Zork never had images. Who here ever played Zork? That was, I just age gapped us. I'm so sorry. I am so sorry. But no, really, so what's super cool about this is all of us intuitively were able to just immediately start assigning properties to these things and grouping them, right? So the challenge is how do we map these groupings in a way that a computer can understand? How do we get that intuitive nature that we have out in the world here, right? So what we're going to do is we're going to take these items, and we're just going to map them in a very simple kind of 2D graph, right? And then we're going to start to assign some values to them, right? So if you take a look at that, the y-axis, my vertical axis, you see wild versus domestic, and then on my bottom x-axis, we have non-living versus living. So just assigning some very simple properties, and then assigning numeric values for those properties, right? Now, you might look at this and say, well, wait a minute, why are the coffee and tea why are they even over at all on aren't they non-living like the computer? Well, they're derived from living things, right? So now you can start to encode some nuance into those values that you're actually storing. Now, this is a super simple two-dimensional example. Vector embeddings are n-dimensional. Real vector embeddings look more like this. This is the phrase computer terminal using OpenAI's text embedding ADA02 model. 1,536 dimensions. So we went from a 2-dimensional array to a 1,536-dimensional array. And if you take a look at the bottom there, you see this little asterisk, right? What's super cool is a text embedding model like this. It's encoding semantic contextual information and stuff into these numeric values. But it's also pulling out things like, a computer terminal is, you type on it, you issue commands, all sorts of things. So it's encoding information into these big arrays. So what can you do with this? So let's take a fun example. I'm going to go ahead, come over to the database. Now, what you're seeing here, this is, so as part of DataStax's AI platform, one of those tools is called AstraDB. This is a fully fledged database that also it's been optimized for, vector storage retrieval, vector calculations, that kind of deal. And what you can do here, I'm going to go ahead and just take one of those example devices used to play video games. And we're going to hit apply. Now, there's something really cool going on here. You're going to see, I'm going to talk about the results in a moment, but what just happened there, right? I just typed in some natural language. I said apply, and then all of a sudden, look at the results here. Look at what just happened. I have these results that came back. Now, top one was a game console. But then all of a sudden, I have these very highly related results. VR headset, speaker, mouse, monitor. And to be sure, this data set is not just, I didn't just like game it with computer stuff, right? There's other things in here. And what's actually happened is every one of these has a description, right? And these descriptions have been vectorized. They have been converted into a vector array, like you see. And then what we're actually doing is when we take this natural language, this is the cool part, that is being converted into a vector embedding. It's being compared to the other vector embeddings that are in the database. But what it's doing that's special is it's actually the algorithm is looking at the distance of the angle between those vectors. You may have heard of like a cosine similarity score or something like that. It's looking at the distance. So the further away something is, the further, the less related, the closer they are, the more related. So these numbers you see here on the side over here, you can see I have a similarity of 0.8 and then 0.7. But as you go down the scale, they get lower and lower. 1 means exact match. 0 would mean no, not a match at all. So what's super cool about this is now with a vector store and the ability, Astra is actually using a feature here called Vectorize that allows you to natively vectorize your information on ingest and at query. So that's how I'm able to do this that's how I'm able to just type in some text, right? But the database does this, and databases are super good at these types of calculations, right? So now I get this way that I can, using natural language, I can pull up some very rich kind of results, more so than I might get with just, say, a keyword search or a wildcard search. All right. Let's come back over here real quick. So that was our basic primer. And we'll pop that back open. All right. So now this gets into RAG, Retrieval Augmented Generation, right? So let's break down the acronym, right? So in a RAG pipeline, what you're actually trying to do, remember the original problem that we had is we had this open-ended question. We don't have context. We need to feed the LLM context. So what we want to do is we want to retrieve some data that we're then going to use to augment the generation of the LLM. So I want to be able to feed data to the LLM so it answers something better than, well, I don't know who you are, I don't have context or something like that, right? All right. So we're going to come back over, and let's do that. All right, a little setup here. So on the right-hand side is a PDF. It just happens to be a PDF that I have on my career, funny enough. And right here, this is the information I really care about, right? In the beginning, when did I start coding and on what, right? Because if I ask this question, and what I'm going to do here real quick is I'm just going to ask a question. I'm going to run this real fast. I'll explain what's going on here in a moment. So similar to what we did with ChatGPT a second ago, I am now running this query, and what it's going to do is say this question is, when did I start coding, right? So this tool that you see, this visual tool is called LangFlow. So it's a way to visually build out GenAI workflows. If you're familiar with LangChain, consider it like a visual IDE or a visual abstraction on top of LangChain, right? So you can just kind of wire everything up and such like that. All right, let's go ahead and collapse this down a little bit. Okay, so what we're doing in a RAG pipeline is actually two things. You have the generative part that's responsible for taking some data and converting it into vector embeddings, things that you can use to search in the database. And then you have a query part, where I'm going to query that same database using natural language, and I'm going to augment the LLM. All right, and here's the key part right here. This is what I actually want you to see. So I'm going to look at this playground. Now notice I don't have any data here. So when I start coding, I got the same answer pretty much as you might have seen for our friend ChatGPT. So I'm going to come down here. I'm going to run this real quick. So what this is going to do is here you can see that I've got this AstroDB component. Now, to be clear, Langflow is totally model and vector and vector store agnostic. Support for all sorts of types of models here. I just happen to use OpenAI for this one, and the same thing with vector stores. So you can kind of drag and drop whatever you want. But in this particular case, what I'm focused on is this database that I've created in AstroDB called Level Up Your RAG, and this collection called Langflow. So now if I come over here, you can see I've got this collection. And here's the fun part. So I've got some data here, and this data actually came from when I just ran through this RAG pipeline. And what it actually does is it's taken that PDF I have, this one here. It's just iterating over it. That's what the split text does. It's iterating over the data in here. It's chunking it into these big chunks of characters, taking those and then converting those into vector embeddings that it's then storing in the vector store. So here, though, is where the fun comes. So we saw a second ago when I did this query, when did I start coding? I don't have the info. But now that I've got this data in the database, I can run this query again. Again, this one is talking to the same exact database. What it's going to do is I'm taking this query, I'm putting that into my search input. I'm going to get some response back. Take a look at my search results here. You see, oh, look, I had these chunks, but now it's actually pulled out a chunk, a relevant chunk, not all of the data, just the relevant chunk based off of my question, my natural language question. Feeds that over to the context. Now, something fun here, this is a super simple prompt template, but I can inject the data right into it, right? So I can very quickly wire these things up. And now this is how we're giving the context to the LLM, right? This is something, you can actually take this out. You can take this whole thing out and pop it into ChatGPT and it would actually give you the right answer. And now if I take a look here, you see, when did I start coding? You started coding games on your Commodore 64 at the age of 8. So it was now able to take the information from that file, the PDF, vectorize it. I could search against it with natural language that it found the closest one to it, took that out, put it into the LLM, and gave us an answer. Now that's great, okay? So, from a development standpoint, it's super cool. I mean, if you're coding and you're trying to build out GenAI stuff, the fact that I can come in here and I can just whip up a flow like this. And by the way, I should mention that in Langflow, there is a vector store RAG template. This is the same thing that I'm doing right here. I've just slightly modified it to add in my database and everything. Okay, now here's the fun part. So we've got this flow. We have it working. We're like, great, I'm getting my RAG data. That's what I want to see. So now let's go to code. And now what I did earlier is all I did was I just started, just for time, right? I started a blank template in Codespaces, right? So this is my blank template. So let's go ahead and I want a file. Okay, great. And let's go ahead, yes. And let's go to our Copilot chat. And let's say, let's build a, or spell correctly, build a basic chatbot using Python and Streamlit. Any Streamlit folks in here? Couple of them. If you're doing Python, by the way, Python's not really known for its wonderful UIs and front end or anything like that. Streamlit's actually pretty awesome because it allows you to very quickly whip up UI code and that kind of deal. Now, something that is super interesting that just happened when they updated Copilot just like an hour ago. Usually, it would give me this code, and then if you didn't know better and didn't realize you had to pip install Streamlit, then I'd go through that step. And I would actually, the cool thing is you can talk to Copilot and be like, dude, what happened, right? And then it'll tell you. But now that it actually says it right up front. So I'm just going to go ahead and follow this. I'm going to say, all right. So that's a cool update, by the way. Yay, Copilot. I'm going to do this real fast. And while that's happening, I'm going to grab the code here. Now, one thing I want to point out, I'm going to be going at a pretty quick clip just because, we have 25 minutes to do this. In the real world, I would highly suggest that anytime you are ever getting code from a code companion or something like that, you're always looking at and understanding what you're actually doing, not just copying it and going, woo, I hope it's good. I think it's best when we treat it like it's augmenting our capabilities, not replacing them or something like that, and you still have to understand what's going on, right? But then I'm going to ignore everything I just said and just do things. All right, so here we have this basic chatbot. Right now, I'm going to go ahead and run this. Streamlit, run, boop, go. And I like to put this directly in my chat. Okay, come back over here. That'll run. Gonna hide this over here. I guess we don't need this. Oh, what happened there? That was new. Yay. Now you know it's real, right? All right, well, let's try that again. You know, this is why I have a baked version. Let me try that one more time just to make sure. Yeah. Let me go ahead and open it. Okay, good. All right, what's going on here, guys? Boop. Yay. All right, good. All right, so now, you know, there's no intelligence in here, right? I just told it to build a basic chatbot, right? You can say, you know, how are you? You know, how can I help you today or whatever? Or if I get rid of this and say hi, whatever, you know, sorry, I don't understand that. Why? Because it's just, there's nothing really going on here. You know, I didn't tell it to do any more. Now, let's take this, and I'm going to go ahead and just highlight this code. And we're going to go back to our friend Copilot. Now, what I really want to do is I'm like, okay, great. I have the basic components of a chatbot here. But I really want to go a step further because I have this flow that I built, this RAG pipeline that now I want to hook my app up to. Now, Langflow has this cool little API in here. There's a bunch of SDKs and everything. You know, you can treat it, you can call this from whatever code. But what I'm going to do is I want to pull this out, and I want Copilot to help me out with this, right? So you can see that I've got some endpoint information, like where is this flow, things like that. This run flow is the thing that calls it. Oh, here's the message. That's my input message, right? You know, here's the endpoint. That's where it's actually going to reach out to connect to you because, now, to be clear, what I'm showing you here is DataStax that's deployed in our cloud service as part of like the database. Langflow, though, itself is an open source and free project. You can go to the GitHub repository, download it, and do this all day, right? So the only difference is that I'm treating this as a service and running it as an API server, right? So, okay, what I'm going to do, oh, yeah, let's see. There's this main in here. You can actually just take this code. It generates it for you for your flow, and you can just put it in your code. I don't want all of it, but that's OK. I'm just going to grab the whole thing. I'm going to come over here, and let's say, OK, using the highlighted code. I like to be explicit with Copilot. OK. No, I want to say, try that again. I'm going to say, using the provided SDK below, modify the highlighted code to implement the SDK. Use messages, messages. Oh my God, that's okay. For user input, and they're actually really good at doing that. And the response for the bot response. If LLMs are any good at anything, they're good at just totally handling misspellings like that. That's all right. Let's see what it does. Okay, now check out what it's already doing. You can tell right away if you take a look up here, it's actually grabbed that part of the code. You can see this run flow with the message and everything. Okay, I mean, it looks okay, right? Obviously, again, we're going faster than I would normally suggest. All right, so now I've got some code. Now let's take a look at it. Let's see what else it told us here. Okay, all right, so let's see. I'm going to go ahead and refresh this. Now I can already see one thing right here is that we do need our application token. So let's go ahead and grab that. Now, because DataStax Langflow in this case, this is on a service, you don't want just anybody to have access to your flow and just like execute your AI stuff and have access to things. So you do need a token. You come here, you say generate token. I'm going to copy that token. I also don't suggest just putting tokens right in your code, but I don't need a .env right now. All right, so let's go ahead and refresh this and say, let's get rid of this. Go. When did I start coding? Okay, I'll hit enter. Now I can tell it's doing something, right? I can tell it's doing something. But I get this, I'm sorry, I don't understand that. And what's going on here? Okay, so I see what I see. So something's going on with the response, and it's not quite getting it. So what I want to do here, let's actually say this. Say, I think the API is working, but I'm getting the error. I'm sorry, I don't understand that. I missed a quote. Okay. Okay, let's see what it has to say about this.
Maybe it's because the endpoint is missing on line 10.
Oh, no, that's actually another way that I'll talk to that in just a moment. Thank you for pointing it out. So here's what it does though. Check this out. So it says in here, oh hey, looks like maybe there's something up the response. Let's add some debugging, right? So this is actually something where I really like this part of Copilot, especially if you run into trouble or have errors or something like that. You can have a conversation with it, and a lot of times it'll help you kind of get down the right direction, right? So what I see it did here, okay, I can see right now after the response, it's got this guy. So what I'm going to do is we're going to come down here, go after my response, and get this out of the way. You know, I don't know about you guys, but at home I actually have multi-screen set up. And, you know, actually I don't want it to, I just want it to print this. So I'm just going to do that. Okay. All right, let's go ahead and refresh. Do this again. And when did I start coding? Oh, now what's interesting is I hit enter, but look what happened here. Check that out. I got a payload, but it's not in my UI, right? So something is working right? So something is working right. So what I want to do now is, now in all essence, would I have maybe figured this out like right away, or did it take me a couple more iterations? You could probably argue that one yourselves. But what I'm going to do is I'm like, all right, I see that it's the API is working. I'm getting a response. It's just not my UI, right? So it seems like I need to do something in here. So what I'm going to do is I'm going to say, I think it's in the response. So let's say modify the highlighted code to, let's see, implement the response correctly using the following JSON payload example. I actually do this in my real coding, by the way. I've, you know, like how many times, like, have any of you work with like an API, you get some kind of response, and you're looking at this huge jumble of stuff, and maybe you prettify it or something like that, but then you're like, okay, just, you know, can we break this down a little bit or maybe explain a little bit? I actually find this is pretty cool. This works out pretty well. Okay, so I see that it did in fact make a change here. So what I want to do is I'm going to grab this part. I believe my cursor is set there, so I'll just grab that out. And now I can see there's a change in the payload, right? Let's pop that in. Hopefully I didn't completely mess that up. And let's try it one more time. When did I start coding? Go. Oh, here I'm still printing that thing out, aren't I? Let's get rid of that. Is it down here in the bottom, though? Is it all the way down here in the bottom? Yes, it did. Ah, there it is. There it is. There it is. Yeah, so let's just do it one more time. We'll clean it up. Right? Was that suspenseful? You were like, oh my God, man, I hope this works for you. You know? Oh, love, I'm doing well. How are you? There we go. There it is. Right, so now, I mean, yeah, it was, what, 4 or 5 commands or something like that. It's a super simple app. This is not anything sophisticated that I would release to production or anything like that. Yeah. But it indeed, right, is now hooked up to that RAG pipeline, and now I can just start talking to it, right? And in Copilot, you know, the capability there allows you to, like, really quickly iterate on these types of flows. So one last thing I'm going to say here about, you know, I get the question a lot, like RAG. Why would you use a RAG pipeline? You know, context windows are huge now. It's not even relevant anymore. And here's the big thing, is that even if you have like 1,000 documents or something like that, and context windows were such that you could throw the whole thing in there, right? Well, now you're paying for all those tokens every time you run it, and it's a lot more processing on the LLM. Databases are already really good at pulling, like holding data and being efficient with that. And with vector databases, you can call the database a lot cheaper, right? And a lot more efficiently and faster than you can with an LLM. So with that, in summary, we learned how to apply context to an LLM in real time with RAG. Got a little bit of vector embeddings primer. Built the RAG chatbot with AstroVectorDB, LangFlow, and Copilot. And now all of you know how to do this. We did it in 25 minutes. So with that, thank you.